All right, so for those of you online, this is where we're at with magnesium hydroxide. So we're going to erase that. So we know we need 2 hydroxide groups. So they cancel out. The charges cancel out. Well, let's do it then. So guide my hand. Electron dot diagram. Tell me what to write down. Oxygen. Okay. Let's try oxygen. What has to be by the oxygen? What do we know? Hydrogen. So I'm going to do exactly what I just did. Same thing, right? Okay. We're good on that so far. What next? Magnesium. Where? On the left side? Right here. Okay? How many, before we fill in the electrons, what element next should I write down? What element?
Oxygen and hydrogen.
An oxygen and hydrogen. Where should I write that oxygen at?
On the other side of
Right here? Okay. And I'm gonna do this same. I'll switch it up. And then hydrogen, you say? Okay, and if I add in my magnesium electrons, are we good? Look good? All right, cool, that's right. Why couldn't I put the hydrogen right here? Yeah, because if I quickly wrote it down like this. So I put the hydrogen in the middle. Well, then this just doesn't work. The oxygen has to be connected to the magnesium. It's cool. Everybody get that? So we work with sulfate, H2SO4. Do we?
We do, yes.
Okay. So a warning, if I were to give H2SO4, it's not going to be written like this, even though it does work out if you do it like this. It won't be written like that. Don't worry too much about that. Just know there's a pattern to it. Okay, any questions on your worksheets? No? They all done?
No.
They don't have to be, but are they all done?
No.
No. Okay. Just lack of time to work on them, or lack of understanding? Time?
Pacing themselves, Mr. Wegg.
The pacing.
That'd be my guess.
Naming stuff, okay. Do we want to work on a naming? We didn't touch on that a whole lot. Yeah, okay, let's do a naming. Well, give me one of them that you believe.
What's this strontium? No, this is strontium.
Beryllium, strontium. Okay. It's D block, isn't it? Isn't it? I believe so. No, it's not.
37, maybe?
Oh, it is. Yeah, it's okay. Never mind. S block. Strontium chloride. So we are writing the chemical formula for strontium chloride. Okay. What's the symbol for strontium? SR. What would the charge be on strontium? +2. Why? Do we know that?
Set plus
It says it in the top right. And it's also in the second column, which often have a +2. So strontium, +2. Chlorine, chloride. Cl, -1. What do we do? Divide by 2. Or, well, least common multiple it. 2 divided 2. 2 divided by 1. 2. Get rid of that 1. We don't need it. We already know it's there. Is that right? Okay, good.
Are you talking about like the other one where you have to write it out, Krista? Or what? Yes.
Like write strontium chloride, the word? No?
I thought that's what you're saying. I don't know how to do it yet. I don't know how to do it.
Okay. What next? Somebody say beryllium bromide? Okay. It's actually very similar to what we just did. So, tell me what to write down. BE. Okay. And BR. What's the charge on BE or beryllium? +2. Bromide. -1. We just did this. Divide by 2.
Can you like do the atomic mass?
Yeah. That's a great question. That was going to be a step in that later. But yes, we'll do that right now. Okay. So, beryllium has an atomic mass of what? 9. Yeah. Let's just go 9. So beryllium has an atomic mass of, and I'm also going to do, I'll do the diagram for it. Yeah. So, and maybe this helps some people, maybe it doesn't. Okay, so we have 1 beryllium. It's 9. We know that. So this arrow, I don't know, it's just pointing to how I'm getting this number. So beryllium, atomic mass 9. Where do you find the atomic mass on your periodic table? At the bottom. Yep. What about bromine? For now, let's just round, but eventually we're going to do decimal places. It's the same thing. It's just math. But let's round just to make life simple. 80. Do we have 1 bromine? We have 2 bromines. So that means we have to have 2 80s, or 2 of its atomic masses. Does that make sense why we do that? And then you just add them up. Equals what? 169. And if someone were to if you're a formula person, atomic mass for this one would equal 9 plus 80 times 2. I don't know how good you guys are. If this is, some people think this way, some people don't. But if you were to put it in this kind of format, don't get confused on this. Just do it this way if you have to. We can do it like that as well. Cool? You want to do another one? No? Everybody's solid.
If I have a charge of like 4, like, or whatever, would you multiply it by 4 instead of 2?
Yeah. Okay, that's a good question. So let's do,
One of those D block elements.
Yeah.
Iron, nickel, or lead?
Okay, let's do iron. Okay, do we want to name it or do we want to do the formula? Formula? Okay. So let's go iron 3 chloride. Is this what you guys were talking about? Is this what we're trying to do? You guys are thinking of? Maybe not. What was your original question?
Oh, like, so like some of it says like PBBR4,
Mm.
multiply it like BR by 4.
Yes. Yep. Okay. Let's try to do. Let's write the formula and the electron dot diagram for iron 3 chloride. An electron dot diagram might be hard, but that's okay.
Wait, Mr. Wade,
Yep.
you have to add the atomic masses of each compound?
No, not on this sheet. I don't think so. Oh, it does. It does. I'm sorry. Yes. Yes, do that.
How do we do that? We just add it together?
We just did it. Yes. You just add the atomic masses together. Yep. Read the directions carefully.
Isn't it IODIN 53?
Oh, shoot.
Iodine. Is that what you wrote? Iodine. Yeah, I swear you said iodine. So it's potassium iodide. See, I don't understand this. Iodine.
How do I explain how to do iron 3 chloride? Just Fe and then 1, 2, 3.
Oh, so quick.
Okay.
Okay, very quickly, one of the things, if you had to write the formula for this, okay, what is the symbol for iron? Fe, okay, and then what's the symbol for the chloride ion? Okay, so then this is why we always say start with your negative ions, okay? And that means the element or elements that have a negative charge. So of these two, which one has a negative charge? Chlorine does, or Cl. But once it forms an ion, that's why it's not iron 3 chlorine, it's iron 3 chloride. This has a -1 charge, but you don't have to guess what iron has for a charge, because when you look inside of that box, okay, the majority of D block elements have more than one charge. Iron does that, manganese does that, nickel does that, copper does that. When you look inside of there, it might say +1, +2, +2, +3, +2, +4. That's where Roman numerals are important, because when you look inside of iron's box, what two choices do you have for a charge?
+3 and +2.
Okay, so we're not going to guess, because that's why when you write these out, it's so important. What type of Roman numeral is that?
3.
Okay, so what do you suppose that's telling you that this has for a charge?
+3.
Okay, so now you're on the home stretch. What's the least common multiple between 1 and 3?
3.
Okay, so if you continually do this, there's absolutely nothing wrong with that. What's 3 divided by 3? We've got 1 here. What's 3 divided by 1? So how many chloride ions do we need? That's why you write it that way. Okay, then you just need to add together the atomic masses, I'm guessing.
Yep.
All right, thank you, Mr. Wagner.
Yes, thank you.
Let me interrupt. So look inside of element number 30, because that's a D block element. That's zinc. How many different types of charges do they have? Is there only one type of charge or more than one? There's only one type, so you do not need to have a Roman numeral for zinc because it only has a +2. But for iron, you have to do that because it can have a +2 charge or a +3. And that's why you don't have to guess. It tells you which one it is. We could, for some of you who want to take this in college, you might say, well, this is ferrous chloride. There's also ferric chloride. One of them is telling you it's +2, one of them is telling you it's +3. But this is by far a long way from college. Right.
Yeah, absolutely. So, is there any question, confusion on what you're doing now? Make sure. What's up? Calculator? Oh, yeah. So, everybody knows how to add up the masses. Make sure we're doing that on the back side. I think just the back side. I didn't read that.
Wait, 70? Oh, I found it. Like if you're
Yeah.
using chlorine, there's 7 extra oxygen, there's 6. Some 4 on the opposite one. So carbon has 3. So that means there's 4 dots
Yeah.
or X's down.
Iron, and then the Roman numeral 3 was behind iron.
Only thing you're missing
How did I know?
is
Yeah.
I
Like,
made that up.
How do you figure
what
that out
type of
though?
charge.
So,
It's like on this one, it doesn't have a Roman numeral.
okay. Yeah, so let's do it in reverse. So, chlorine has a -1, right? And there's 3 of them there, right? So multiply 1 times 3 and tells you this, right? You're just doing it in reverse. Yeah.
Is that the right atomic mass? I just did.
Chlorine, 2 chlorine. Oh,
I
sorry,
did
that's right.
35 plus 35 plus
70 plus 65 is 135. Yep.
If you did that, if you call this lead 2 bromide, you only have 1 lead. So for
Okay.
every 1
I think we're
lead,
good,
that's
right?
2 charge.
Goodbye, Internet.